DEF. This does a really good job about the very basics of DEF and has animation about what goes on within the engine and the exhaust system with it, which I thought was a clearer explanation than what I could do verbally. So let's watch this a second.
DEF is part of the solution to the problem of NOx abatement. Nitrogen dioxide, or NOx, is a gas in the exhaust of diesel trucks and off-road equipment. Because NOx pollution is linked to serious respiratory problems, the EPA has been decreasing limits on NOx output since 1994. To meet the 2010 limits, a different approach was required. Today, manufacturers agree that the most effective technology to reduce NOx is selective catalytic reduction, or SCR. Starting in 2010, most newly manufactured trucks use SCR and DEF. SCR is an after-treatment technology that is part of the exhaust system. By treating the NOx in the exhaust system instead of in the engine itself, the engine can operate at peak efficiency. So, SCR not only cuts NOx emissions, but also improves fuel economy. The SCR system has four main components: the DEF tank, the particulate filter, the DEF injection system, and the SCR catalyst. The exhaust leaves the engine and enters the particulate filter, where carbon particles, or soot, are captured. As the exhaust leaves the filter, a mist of diesel exhaust fluid, or DEF, is sprayed into the hot exhaust stream, where it turns into ammonia. Together, the NOx and ammonia pass through the SCR catalyst, where they react chemically and transform into harmless water vapor and nitrogen. Nitrogen is actually the most common element in the air we breathe. The SCR system reduces NOx emissions to almost zero.
Okay, like I said, that was brief, but that gives you a little bit of idea of mechanically what's going on in the system. And we'll talk a little bit about this. I mentioned this, the DEF is defined by this ISO standard, this 22241. This is a little bit different than how we do motor oil or antifreeze. You know, in motor oil, the engine manufacturers say, you know, I want whatever oil you guys come up with has got to do this in the car. It's got to prevent this kind of wear under these conditions and that sort of thing. And all the oil companies run off and come up with their different formulations of base oils and additives and polymers, you know, to make something that meets the requirements of the engine manufacturer, right? This is different. The ISO standard tells you DEF is this plus this. End of story, right? There's no room for my DEF to be different than your DEF in terms of formulation. So DEF is built to a very specific standard. It's also, you'll also see it referred to as this AUS 32 and ARLA 32. Not highly common here. These acronyms also developed in Europe, where this was started. You can see there's been rapid growth in the US and projected further growth. This started in 2010 as a requirement, zero before that. And of course has been growing a lot. And if you've been buying rigs, you guys know why. It had been in Europe for several years, or at least a few years before that. So at least we allowed the Europeans to figure out some of the gotchas behind all the DEF systems and the challenges for that. All right, as a bonus today, you know I like to sit up here and tell you the formula for things. I'm going to give you the formula for DEF, so you get two formulas today. The diesel exhaust fluid, 67.5% water, 32.5% urea. All right? Not just any water, deionized or distilled water. Very, very clean, very, very pure water. Okay? Not any kind of regular water. It's got to be extremely pure. And the urea. Urea is a very high purity grade. So you cannot use agricultural grade urea, which is used as a fertilizer, for instance. Very critical that it be pure. The reason they use urea, or a reason they use urea, and you saw it briefly, or kind of mentioned in the video, the real reaction that takes place that turns nitrous oxides into nitrogen and water. The reaction is between the nitrous oxides and ammonia. Okay, that's what's really happening there. Has anybody here ever dealt with industrial ammonia? Not just cleaning ammonia, but industrial ammonia? Yeah. Anybody who's ever wonder why these places that are big refrigerated warehouses all have a big orange windsock outside? It's because they have ammonia refrigeration systems, and if there's an ammonia leak, you need to know which way to run. Okay? Ammonia is pretty nasty stuff in its pure grade, and nobody wants to be carrying a container of pure ammonia on a truck, much less have every truck with a container of ammonia on it running around. So you can take this DEF stuff, the urea stuff, which is vastly less toxic, and have that in your container, and in the exhaust system, right after it's injected and before it goes into that catalyst is the only time it's ammonia, right? The urea turns into ammonia, and then the ammonia does the reaction. So this is a much safer way to handle this. That 32.5 number is the one that gives the lowest freezing point. All right, that's why that particular percentage was chosen as part of the standard. The ISO standard itself, that 22281, actually allows it to be in the range of 31.8 to 33.2. In most cases, the sensors on an engine, picking these things up to figure out if your DEF is in grade, somewhere in the range of 31%, 34%. As long as it's in that range, you won't trigger anything. And I did mention that it was non-toxic, and it also cleans up pretty easily. The recommended ways of cleaning this up frequently is just to let it dry into its little white crystals and then sweep it up or vacuum it up. Okay? But the critical thing about DEF is in the handling. Okay? It must be kept clean. Okay? The downstream exhaust system parts are very, very sensitive. That catalytic converter, very, very sensitive. So it must be kept very clean, and we'll talk about that. I got a slide on that. It's corrosive to many materials. Okay? This is something people are not aware of, or if they're not, they learn about it soon enough. And it also likes to leak, sometimes called creeping. And if you've tried to contain this stuff, you know that it likes to find its way out through whatever tiniest crack it can. So here's the we'll talk about the DEF cleanliness, because I've got some specification information. Now, I don't know if you can read these very, very small numbers, the kinds of amounts of contaminants that can be in here. Okay? 0.00005% allowed of sodium, for instance, or many of these other items in here. And that's the maximum allowed before this stuff is considered out of specification. All right? You can very easily see how a little bit of calcium from water would throw this off, because most waters have, tap waters have a lot more calcium than that in there. Here is my example. This, if you can envision a transport truck, 5,500 gallons of DEF. Okay, this is a teaspoon of salt. All right, that will throw that specification out of whack on that entire transport truck. We'll throw it over the sodium limit. Okay, very, very sensitive to contaminants. So keeping this stuff clean, very important. Treat it like you'll drink it, is what I say. Now, don't go drinking it, all right? But give it that kind of respect, okay? Keeping it clean. All right? I mentioned that it's corrosive to many materials. So having the right materials for storage and dispensing, very important. Stainless steel, that's the most common steel component used in these systems. There are other steels that are also compatible, but nobody wants to make a tank out of titanium, right? Stainless steel is real common used. Plastics, many plastics are compatible. If it starts with poly and ends with ene, it's probably compatible. Polystyrene, polybutene, polypropylene, all those guys. Those are the case. But we want to make sure you get a good quality plastic that hasn't been made with specific additives. Some plastics are made with, integrated with additives for various reasons, but you don't want those additives leaching out into the DEF, and again, that would cause contamination. Okay? In terms of incompatible materials, do not use, and this is because everybody says, hey, we got that old oil tank that's sitting over here. We could make that our DEF tank, right? Yeah, don't use carbon steels, any kind of galvanized steel, or anything with zinc. Any of the yellow metals, copper and brass, bronze, even for fittings, these are all no-nos. Aluminum would be pretty corrosive to aluminum. Anything with solder or magnesium, okay? These are all incompatible materials. All right, let's step into the quagmire that is shelf life on DEF. Lots of questions, confusion, sometimes bad evidence. Okay, what can we say about the shelf life of this stuff? Well, the first I'll say is it's not affected by freeze-thaw cycles. So you can take that box of DEF and put it in the freezer and pull it out, let it thaw out, it'll still be just as good, right? So freezing it does not affect the components of it at all. On the other end of the temperature spectrum is another story. The rule of thumb on these things is that if you can store it below 82 degrees, you get a shelf life of 2 years. Okay? 2 years stored below 82 degrees. All right? Now, how many people's shops here are 82 degrees or less? Right? Okay, so there's some compromise involved, and you've seen these charts. I remember when these charts first came out, I was playing around with it, trying to figure out what temperature it had to be for the stuff to last 5 minutes. It was, and there are a number of factors that come into the life on this. You do have to get, it's not the ambient temperature; it is the temperature of the product. Some of these, as the temperature goes high, these charts aren't exactly accurate, and it depends if it's constant. So if you've got something, even in Arizona, it's not at those high temperatures 24 hours, right? It still carries some cycle with it. But it does degrade as the temperature goes up. So you want to make sure, one, that you buy fresh stuff, right? This is not the kind of thing you hang around at a flea market and buy from the back of a guy selling a stack of it somewhere. And two, you carefully manage your inventory. Make sure you're turning over your product. You don't overbuy. You don't say, we got 2 trucks now. We're going to get some more in the future, but let's save some money by buying a tote for our 2 trucks, right? And so you need to carefully keep that in mind as part of your inventory and storage function. Okay, we'll talk really briefly here about sampling and testing. There's not a whole lot of, it's a pretty simple stuff, we already said, right? There's not even any additives. We got water and urea, so there's not a whole lot of stuff to test for. And you can do this at home. Appearance. If it's clear and it's clean and it's water white, you're most of the way there. If it's not any of these things, then you might have a problem, right? So we already talked about how clean it needed to be. If you can see stuff in there, you're not there. The other thing to measure on here is the concentration. How do you have your 32.5%? And once again, you use a refractometer. This one we have over here has been calibrated and a little screen inside designed for DEF, so there's a little 32.5 bar in there, and you go look for it, and it's pretty easy to see if you're where you're at. And again, after this session, if you want to come up here and play with this stuff, please do. So you can use a refractometer, or you can use a float tester if you don't have a refractometer, for getting an idea of are you in the right concentration level. Okay, and then we will also, I think we're getting towards the end here, because I'm going to talk about dispensing DEF. Dispensing DEF is kind of an evolution. This is what we observed in our time in this market. You know, somebody buys one truck, maybe two trucks, they're going to buy a jug. Eventually you work their way up to a box. Now you got to get a barrel because you got another rig or two. Eventually you get yourself a tote, and then maybe some sort of a complete system with, insulation and closed off connections and that sort of thing. All right? Your takeaway from this should be that easy dispensing leads to improved cleanliness. Okay? So make sure you've got it easy for yourself or your staff to get the product into the vehicle in a clean manner, whether your hose is long enough. What you don't want is to have a situation where the guy's got to fill up a plastic bucket over here with the stuff and then walk across the yard and pull out a funnel and put it in and try to, keep it as clean as possible, make the dispensing as easy as possible. All right. You guys, most people know that we sell DEF and have been doing it for some time. We're also in the DEF equipment business, which people may not know. In addition, we've arranged ourselves with our suppliers to offer a 3-year warranty on our DEF dispensing equipment, which we think is at least the best in the market, maybe better than anybody, but we don't know of anybody that's got anything greater than 3 years. Our deliveries in bulk are calibrated to weights and measures, so you know what you're getting. We've got 7+ years of this stuff. I mean, since it came into the market, we've been on top of it. And we also have this product available to us, or available to you, at our card lock sites, the Petrostop card lock sites. All right. Okay. Any DEF questions? We'll go with you first, Tom. Yeah, the question is will, if you got DEF in a container in your truck and it's sitting unused for 2 months, 3 months, any amount of time like that, will it go bad? The short answer is it can, and it will. Now it does depend on, and that's whether it's in the saddle tank on the truck sitting there, or whether it's a box of that stuff sitting behind the seat. Okay, it literally all depends on what temperature the stuff in there gets to. All right, depending on how the windows are set up and if it's in a shade and stuff like that. If it's 110 out, what's in that bucket still may only be in the high 90s. Okay, so it's not at 110, but the high 90s is still going to degrade the stuff over time. Yeah, and the theory is, theoretically you wouldn't have to. Okay, these things are closed loop systems. I mean, the way they theoretically should work is, as the exhaust is coming out, there's a sensor there, and it says, oh, you know what? It's not all being converted. All the NOx is not being converted. I need to pump in more DEF. And the reason the NOx wasn't being converted is because with the DEF being pumped in, the volume of it was, reduced from that. So theoretically, it should be a loop system where it starts pumping in more DEF until the exhaust sensor says, oh, there's no more NOx coming out the final exhaust pipe. All right, that's the closed loop way it theoretically works. The engine manufacturers don't allow that to be a complete loop, though. They have a limit. At some point, they're going to shut that down, probably put you into a limp mode or something like that, I would guess. The question is are you trying to keep, they have tarps around, are you trying to keep the sun from getting it, or are you trying to keep the temperature down? Okay. Everything that I've read has said temperature, that it's all temperature related. and that it's not UV related or some, like something like that, which can have effects. But I'm not so sure that there aren't radiant effects that you're blocking with a tarp that are not just thermal, but there's actually some other radiation kind of thing. But if my first order thinking on that is it is temperature, because temperature is a known deal, and having a tarp over there will reduce the temperature due to the radiation effects of the sun. But that is a good question. Yeah, and not necessarily UV. Like there are products you want to keep out of the sun because of UV exposure. Well, you're probably not doing it any favors. Well, first of all, by being in a steel container instead of plastic, right? And it's like you're probably not doing yourself any favor. But the amount of time that it's spending in there, it's not going to probably get any hotter there than it is once you've dispensed it into the piece of equipment you're going into. So, at that point, you're so close to consuming it that it doesn't matter as much. There is a possibility that you can run into some problems with the water part of it evaporating. Yeah, and if you've got crystals that are in there, then the crystals can probably go and end up with some plugging problems with filtration and be a joyous nightmare. Yeah, I was going to say well, there probably shouldn't be a brass valve on the bottom. It's because of the brass. The brass will get corroded. Some portion of that brass will actually end up in the DEF, and the brass part itself will get corroded away, get pitted, discolored by the DEF itself. Yeah. Assuming that you are going through that much DEF, that's important, right? But that works from a thermal point of view. The bigger chunk of DEF you've got, the less susceptible it is to the cycle of temperature going up and down, okay? It's more of a damped motion day to night going up and down. And as a result, you're at a net lower temperature, you get a little bit longer life, as well as the evaporative issues. So. Yep, if you're using an oat as on those, you can do away with those additive filters, definitely. Yeah, the question was he's got a couple of units that are running OATs, the ELC products in the antifreeze. Wanted to confirm that the filter in that system, which is an additive type filter, can be replaced with a non-additive type filter, and the answer is yes.